If the cost of electricity required to deposit 1 gram of aluminium is 4 naira, how much would it cost to deposit 24 gram of copper? Aluminium is 27, copper is 64. Hello guys, welcome to Learn Chemistry with Onyinye, and today we're going to be solving a question on the electrolysis. And like I read, this question is asking us to find how much it would cost to deposit 24 gram of copper. Now, in this video, I solved a similar question, and I told you when you see a question where the first sentence is asking you about a particular element, then a second sentence follows asking you about an entirely different element, then that question likely is going to fall under the second law of electrolysis. So this question we have here falls under the second law of electrolysis. And in this video, I explained that in second law of electrolysis, the quantity of electricity between the two elements involved automatically becomes the same. And when I say quantity of electricity, I mean this, Faraday. Now, Faraday is measured in coulomb, and quantity of electricity, which can be transcribed to current times time, is also measured in coulomb. However, when I say quantity of electricity here, I mean this, Faraday. So, means that the quantity of electricity that 1 gram of aluminium will deposit is the same, or is how much quantity of electricity that 1 gram of copper will also deposit. Now, do you get this? All right, so let's see how we can solve this question. Remember, the quantity of electricity for the amount of metal deposited would correspond to the quantity of electricity for the amount of metal deposited here. Now, we're given the mass of aluminium. Now, this is what we are looking for, right? Faraday, quantity of what? Electricity. Now, how do we get this? In place of no time, no Q, no N, no V. Sorry, N is always given, F we know, but no time, no Q. So how do we get this? Now, aluminium in electrolysis, once this has 3 electrons, once it gives off this 3 electrons, it's going to form no more aluminium. While copper has 2 valence electrons, and once it gives it out, you're going to have no more copper. So from the half equation of aluminium, it means that 1 mole of Faraday would require 3, this 3 here, Faraday of electricity. Remember the formula, mass over molar mass equal to Q over N, N representing this, that is oxidation number, times F. This F, of course, is this F here. So this N is this 3 here, this F is this F here. Now, just for reference, okay? So 1 mole of aluminium is going to give us 3 Faraday. From this question, do we have mole here? No. However, we can get the mole of the respective elements. We can get mole for aluminium. We can get the mole for copper. So what's number of mole? Remember the formula, mass over molar mass. So for aluminium, we have 1 over, what's the molar mass of aluminium? 27. So 1 divided by 27 is 0.037. So if 1 mole of aluminium require 3 Faraday of electricity, 0.037 mole of aluminium will require how much electricity? So X times 1 is X, and this times 3, it's 0.111. So we're going to have 0.111 Faraday of electricity. So this 1 gram of aluminium translated into 0.037 mole of aluminium, it's going to require 0.111 Faraday of electricity. This automatically means that this quantity of electricity is required to, the cost is 4 naira. So this quantity of electricity is what? 4 naira. For which element? Aluminium. If the quantity of electricity for that amount of element deposited for the two elements, different elements side by side, automatically becomes the same. It means that this quantity of electricity will also be required for 1 gram of copper. Do you get? So 0.011411 Faraday is required for 1 gram of what? Aluminium. This same thing is also required for 1 gram of copper. Hence, this can be used also for your copper. Now, if this requires 4 naira, what will this 24 gram of copper require? Now we can find that from here. So let's clean this. Just like we did to aluminium, 1 mole of copper. Now this is 1 mole and not 1 gram. 1 mole. Mole is different from gram. So 1 mole of copper here requires 2 Faraday of electricity. Now look for more from here. You get mass over molar mass. What's the mass here is 24. Molar mass is 64. So 24 divided by 64 is 0.375. So 0.375 mole will require X. So times 2, so X is 0.75. Like I said, 0.11 Faraday, although we got it from aluminium, the amount of electricity deposited for this mass of aluminium will correspond to the amount of electricity that will be deposited for this same mass of copper. So it corresponds. So for copper now, if 0.11 Faraday gives 4 naira, it's required 4 naira. What will 0.75 Faraday require? So 0.75 times 4 equal to divided by 0.111. So we have 27.02. Remember we're talking about naira, so naira. Now come to your options. You have A 27.02, B 37.02, C 47.02, D 7.02. So this answer corresponds, and this is your answer. Remember, the second law of electricity, two elements placed side by side. The quantity of electricity required to discharge the same amount of elements will be the same. Now, I hope you understand this.